Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the starting material. The starting material is propyne, CH3, a terminal alkyne with the triple bond between C2 and C3. Moving on to the next step. Reaction with HgSO4H2SO4, acid-catalyzed hydration of alkyne. For terminal alkynes, Markovnikov's rule applies. The O adds to the more substituted carbon, C2, and H adds to the terminal carbon, C1 of the triple bond, which is C3 of the chain. This gives an enol intermediate that tautomerases to the more stable ketone. For propyne, CH3CCH, the product A is acetone. Wait, let me reconsider. Propyne is CH3CCH. The triple bond carbons are C2, internal, bearing CH3, and C3, terminal. By Markovnikov addition, O adds to C2, more substituted, giving the enol CH3C. O is equal to CH2, which tautomerases to CH3, co-CH3, acetone, propane, to -1. So A is equal to acetone, a ketone. Moving on to the next step. Reaction of A, acetone, with NaBH4. NaBH4 is a mild reducing agent that reduces ketones and aldehydes to alcohols. Acetone, CH3, co-CH3, is reduced to 2-propanol, CH3CH, of CH3. And for the final step, product B is equal to 2-propanol. A. Propanol is vague but if meaning 1-propanol, incorrect. C. 1-propanol would result if hydration followed anti-Markovnikov addition, which does not occur under HgSO4H2SO4 conditions. D. Propane is not formed. NaBH4 reduces the carbonyl to an alcohol, not fully to an alkane. Therefore, the correct answer is B. Therefore, the correct answer is option B.